I'm going to read it and annotate it. So, an airplane is sighted at the same time by two ground observers who are 5 miles apart and both directly west of the airplane. So before I do anything else, I highly encourage that we draw the story and then let the triangle come from the story. So what's the story about? There are two ground observers, two people on the ground. So I'll draw the ground here. There's two people on the ground. Now where are they on the ground? They are both directly west. There are my happy ground observers. Look how happy they are. They are how many miles apart? And then what do they see in the air? I don't claim to be very good at this. Hey, I appreciate your niceties. But they both see a plane, and then we can go from there. So can you at least draw that much? Thank you. Mike, you got to go. So, they report angles of elevation. Now, what is angles of elevation? That's from the ground looking up to the plane. So, from the ground to the plane, from the ground to the plane, can we draw those two lines looking up to the plane? Now, one is 15 degrees. Shh. I need you to use some common sense. You ready? You got it in you. The one closer to the plane or further away from the plane should be 15 degrees. Should try one more time to think. Yeah, further away one. The closer you are looking up, it would be a bigger angle, correct? And then, what am I asked to find? And when you're talking about height, height always makes an angle of 90 degrees. So, if we choose not to draw the story first, there's a chance you might draw that incorrectly, right? In terms of what's happening in the story. So there we are. That's where we're starting, and what's our goal? Hey, we have triangles here to unpack. Can you solve the puzzle of the triangles, find missing angles and sides to get to what goal? So can anyone tell me some things I can find in that triangle that might help me? I could find a side. What's easy to find that's going to be helpful? Do you see this angle beside 25? That's going to be helpful. What's the angle beside 25? Do you know that 25 plus whatever has to equal 180? So this angle must be 100 and... Is that right? Now, the reason I said this angle is helpful is because what's the only side I know the length of? The only one? 5, right? So guess what angle is opposite of it that I'm going to need? Because I have nowhere else to start. So now do I know two angles in that obtuse triangle? How do I find this angle up there? Add and subtract 180. So what's left? What's this angle up here? Oh, I'm recording. I forgot. 10 degrees, yay? Did you see how I got 10 degrees? 155 plus 15, and then what adds to 180, right? It has to add up to 180. So I am going to start with sine 10 over what? Okay, next. I can't solve for h directly because 5 is not in a triangle that's going to help me for h yet. But I want you to notice that there is a side that's shared by the triangle that has h in it and what I'm looking at. Can you see a shared side? Where is it? Do you see it? I'm going to label that x, the shared side. What angle is opposite of it? So sine 15 over x. All right, I need you to use your calculator. And it's 5 times sine 15 divided by sine 10. We're just going to round to 3 decimal places. Oops, silliness. All right. So 7.452, and that's in miles, correct? Now, my goal is to solve for h. Do I now know a side in that right triangle? Do I know an angle in that right triangle? We need to use Sohcahtoa. I'll even write that down. Sohcahtoa. From 25 degrees, what is h? H is the opposite side. What's x? Which one is opposite and hypotenuse? Sine. So the sine of what angle is equal to opposite over hypotenuse. And we know what x is, so I'm going to put that number in, 7.452. How would you get h by itself? Multiply. So in your calculator, multiply 7.452 and sine 25. So what is the height of the airplane? And the answer is 3.149 miles. I need you to read number 2. I need you to annotate it, and I need you to do your best to draw the story and then the triangle. These stories could be law of sines, law of cosines, right triangle trigonometry, or a combination, right? Your goal is to draw it and then think your way through the triangles, yes, to get the answer you need. All of you are amazing mathematicians that can do this. So, let's read this, annotate it. The person that is too shy to draw a picture because they're embarrassed that they can't draw well, I can tell you that if someone gave me an honest grade in art in school, that would have been my worst grade. That and handwriting. Those are the two we said grades. So I know it. And then you just have to keep working through it. It's not what I'm gifted at. I wish I was, because I respect artists. So I don't want to draw the picture. You don't know where to start. Start with the nouns. What are the objects in the story? Can you start there and draw the objects? Please? Surveyor? Yeah. Someone who surveys. So, isn't that a great definition? A surveyor is someone. So ultimately, you don't really care. It's a person, right? Whatever they do, they do. But if you really want to know a surveyor, when there's a new piece of land and they have to do grading, and the person sets up a transit and looks through it and makes sure that things are level or things are graded in a way where things don't flood, right? They're drained properly. Like the person that sets up the good stuff to look at it, you know. Sometimes when they do that on streets on the corner, someone sets up a little tripod and looks through it, right? That's like a surveyor. Surveyor is someone who sees. But you should just draw a person. And a happy stick figure is okay.
What is it?
A surveyor is a person who surveys, is standing 50 meters from the base of a building. Don't go any further. Draw that story, just that sentence. Can you draw it? So I need the ground, right? I need a person. There he is. And then he's standing 50 meters from a building. Now, he measures to the top of the building, and what does he find the angle to be the top? 39 degrees. Am I so far just reading the story and filling it in? He then measures the angle to the top of the radio tower on the building. So on the building there's a radio tower. So that whatever you want to draw, there's something on top of the building, right? A tower?
Yeah.
And then measures to the top of the tower, right? And now that angle is, and it's the whole angle, is 50. And we know the distance here to the base again is not only 50 degrees, but this is also 50 meters. So let's start there. Our goal is, how tall is the tower? Yes? So, first of all, do you see the right triangle that's out of that? Do you see two right triangles? I'm going to go draw two right triangles. You ready? So I'm going to draw one right triangle that goes way to the top and only the right triangle. I know the base of that triangle is 50 meters. I know the angle to the top is 50. And I just want to find what that side is. That will take me from the ground to the top of the tower. Yes? Let's do that. Sohcahtoa. Which one do I use to solve for x? Circle the angle. Okay, I like that you tried. So, circle the angle. Opposite over adjacent. I know, you miss all the shots you don't take, right? So I appreciate you tried. Sine is wrong, right? What I did, I just heard that, right? Tangent, 50 is equal to what? X over 50. How do I get x by itself? To multiply by. So let's do this. So the approximate height from the ground to the top is 59.588. Yes? Meters? Okay, we're going to draw another triangle. This time, the triangle, still 50 meters, but now the angle's not 50, but now the angle is 39. Now, 39 degrees gets me to the bottom of the tower, right on top of the building? Again, which Sohcahtoa, which one am I going to use here? Same one, right? So tangent of 39 is y over 50. How do I get y by itself again? Multiply by 50. All right, so again, use your calculator. And you get 40.489. The question is the height of the tower. What do you think I need to do to find the height of the tower? Are you telling me if I go x subtract y? Because what I found was all the way to the top of the tower. I found all the way to the bottom of the tower. If I subtract those two, that would give me the height of the tower. So let's do it. Subtract. And h is equal to, the height is 19.099. So pretty well 19 meters. I need you to read number 3. We get stronger when we practice with a great attitude. So number 3, annotate and draw the story. Usually you should start drawing after the first sentence. But feel free to read the whole thing. but then go back to the first sentence. What are the objects? And draw it. No boat. Okay, shh. What do we have here? A ship that's sailing parallel to the shore. Is that right? And what else do we have? All right, here we go. I can't draw it. There's my lighthouse. When I get frustrated, I just start scribbling. But there's my lighthouse. So, in the water, I have a boat. Is that right? And then, when it spots the lighthouse, what angle does it make to the lighthouse? And that angle is like the angle of elevation. So the angle is 22. Oh no, first it's 15 degrees, right? Then what does the boat do? 4 more miles, right? Now what's the angle? 4 more miles. So instead of 15 degrees, it's now closer, so it's a bigger angle. 22 degrees. We know that this distance here is 4 miles, and it says, how far is the ship from the lighthouse? That'd be directly there. That is what I'm solving for. So a ship is going parallel, right, to the shore. It spots a lighthouse, and the angle it makes is 15 degrees. Goes 4 miles, does the angle again, and now that it's closer, the angle is bigger, so it's 22. And the question is, how far is the boat from the lighthouse? Now you need to unpack that triangle. Hey, what parts can you find right now? What would be helpful? What's the only side I know? What angle is opposite of it? So your goal is, how do I get that? Go for it. How do I get the angle opposite of 4 miles? Think. Unpack the triangle. Think through the triangle. I can't use the law of cosines if I don't know at least 2 sides. So if I only know one side, and it's not a right triangle, the only law I can use is the law of sines, right? So this angle in here is 158, is that right? And then 158 and 15, what do they add up to? So, can I tell you a short way to get 7 degrees? This is a triangle property. Do you notice the angle here, 15, and this is called an external angle that's outside the triangle, is 22? What happens when you subtract them? And that's the way it's always going to be. Because these are supplementary 180, so subtracting them is a quick way to get that angle up there too. That's a property. Okay? Okay, use the law of sines. I need you to solve for this side using the law of sines. Go. All right, so sine 7 over 4. What angle is opposite of x? So sine 15 over x. To get x by itself, you're going to go 4 times sine 15 divided by sine 7, and it's over. So, how far is the boat from the lighthouse? And it's 8.495 miles. Turn the page. All right, we're on to number 4. I need you to annotate and read and draw the picture. All right, so read number 4, annotate and draw the story. Hey, does this one seem familiar? So, what is it? Oh, they're directly east, aren't they? East. Hey, what's east mean? All right, so we have a rocket here, and they're east of it. So there's A, and there's B, and they're east of that rocket. They are 2.5 miles apart. It says that angle A reports an angle of 28 and angle B. So actually, which one's closer then? A or B? B is closer because it has a bigger angle, right? So B is closer than A. And it says, what's the distance from the telescope to, which telescope? The rocket to B, right here. All right. Do you remember how quickly we're going to find that angle that's opposite of 2.5? What's 60 subtract 28? 60 subtract 28. So what angle is opposite of 2.5? So I'm going to go sine 32 over 2.5. What's the angle opposite of x? So it's sine 28 over x, and then solve it. And the answer is 2.215 miles. Number 5. A guy wire is just a wire that keeps something from falling down. And they call that wire that you attach so it doesn't fall down a guy wire. I don't know. It was like 100 years ago when things were incorporated. I don't know. It's like they should call it a female wire. I don't know why they call it a guy wire. No, I don't know. I honestly don't know why it's called a guy wire. Maybe it has nothing to do with guys. I have no idea. But I know that when there's something really tall and it can fall down, they attach a wire to the ground so it doesn't fall down. They call it a guy wire. But whatever. I think we should change the name of it. I think it should be the wire that doesn't make the tower fall down wire. So what are we going to draw? A tower. Can you draw a tower? Is the wire attached to the top? It says top, right? Hey, there's my tower. I'm going to attach a wire to the top, and it makes an angle of 50 degrees at a point 25 feet further along the ground. And in line with the base of the wire, the angle to the top is now what? The angle is now 20. Hey.
Does it matter which way that you draw it?
No, so if the tower is on the right side and you do it, it would be the same. So you can take the picture and flip it and it's fine. But which angle must be closest to the tower? And the one further away? And there must be, between those two angles, the distance is 20. We've done these, right? Guess what that little angle up there is, opposite of 25. What do we do with these angles? So that angle up there is 30, right? Let's go. And then what's my goal to find? What the length of the wire? Remember which of these lines? Which one of these lines is the wire? The one with 50. So label it and then use which law and solve it. So that angle up there is 30. So sine 30 over 25. What angle is opposite of x? Sine 20 over x, and then solve it. So it's 25 times sine 20 divided by sine 30. And so the wire's about 17 feet, right? All right, number 6. That's right, a ship at sea, the Admiral, that's the name of the ship, spots two other ships, the Barstow and Coldrew, and measures the angle between them at 45 degrees. Even if you don't read anything else, what should you draw first? A ship.
Yes.
You can label the ship A for Admiral. And then how many ships does it spot? So you need how many more ships? So altogether, how many ships? And it doesn't have to look exactly like mine. But did you have a ship and the angle between the two boats is 45 degrees? It says the other boat, Barstow, the angle between the two boats is 59 degrees. And then the distance from the Admiral to the Barstow is 323. What's this distance from the Barstow to the Winslow? Step 1. Guess what you have to find first? What angle is opposite of 323? So 180, subtract 45, subtract 59. What's the last angle in there? So I start with sine 76 over 323. What angle's opposite of x? So sine 45 over x, and then get x by itself, and you have your answer. So how far is the Barstow from the Caldrew? And the answer is about 235 meters. Turn the page. Two surveyors are 180 meters apart on the same side of the river. Measure their angles to a point between them on the other side of the river and gets those two angles. So I'm going to draw a river. There's my river. These are ugly? Thank you. Thank you. So here are my two observers. And they spot something in between them on the other side of the river. And then they said the angle to that, one angle is 54, the other angle is 68. This one, it doesn't matter which one's on which. How far from the point is each surveyor? So I need to find this side, and I need to find that side. And we know they're 180 meters apart. So how far is each surveyor from the point? Step number 1, 180, take away 54, take away 68. So that angle up there is 58. So sine 180 over, or sine 58 I mean, sine 58 over 180. If I want to find x, it's sine 68 over x. And then to get x by itself, it's 180 sine 68 over sine 58. No, you can throw it away. And so for surveyor X, it's 196.797 meters. To find Y, I start the same way, but this time for Y, I'm going to use 54 degrees. And then to get Y by itself, it's 180 sine 54 over sine 58. So it's almost the same one, right? You just change 68 to 58. No, I mean 68 to 54. And so surveyor Y is 171.716 meters away from the point. All right, read number 8. All right, a flagpole is perpendicular to the horizontal, but is on a slope that rises 10 degrees from the horizontal. The flagpole casts a 43-foot shadow along the slope at an angle of elevation from the slope is 36 degrees. How tall is the pole? See if we can draw it. Good. See if I can draw this right. Yeah, the sun's going to be in the way. So, All right, we still have a good 10 minutes left to keep working on trig stories. That's what you're going to see tomorrow, right? You'll see that on your exam for trigonometry. I'm trying to give a moment of just practicing together as best we can. I want to figure out how tall this flagpole. It sits on a slope that's how many degrees? And from the end of the ramp to the sun, the angle is, actually it shouldn't be from here, should it? The angle up there to the sun. But when it says angle of elevation, it's made with horizontal. And that angle up to there is 36. We know this slope right here, the shadow of it on the slope is how long? So, if the angle of elevation is made with the horizontal, and the slope is 10 degrees for the slant of the hill, what's this angle in here then? What would I do to 36 and 10 to find this angle? Subtract. So this angle in here is 26. So what angle do I need to find that's going to help me out here? Because I need to know the angle opposite of. So this angle in here is what? 26. What's another angle that's going to help me out? What's this angle right there in that bottom right triangle? 80? Because 10 plus 80 and 90, right? That means the angle on the other side must be 100 degrees. See how I'm working through the triangles? And then, the very end, 180 take away 100, take away 26. What's this angle opposite of 43 feet? So that angle up there is 54. So, the sine of 54 over 43. What angle's opposite of the flag? Sine 26 over x. And then get x by itself. And solve it. For some of you to be successful, you might have to print this out, like make blank again and go over it again slowly, because you're not in the mood to challenge yourself, to read, annotate, draw the picture. And guess what? Trigonometry, you're discovering is, dang it, I got to think through these things, right? It's not the same way every time, and I just want a cookie-cutter way to solve. And I'm telling you, the ones that enjoy this puzzle, they're going to be successful. If you just whatever it in your brain, then you're just going to get F's and D's on this. Because you're not developing the part of your brain that wants to solve this, right? All right, so the height of the flagpole is is round to the nearest 0.1, so 23.3. That's how tall the flagpole is. All right, number 9. This will be our last one. That means the others I'm going to put on video, and you need to practice to get stronger at this, or ignore it and then see where your quiz grades go, right? I don't want that. So, number 9, last one together. Then, part of your homework, I'm going to put the other ones on video too that you can practice with me slowly so we can get better, okay? This should also help you correct your quizzes today, because today's your last day before tomorrow's the quiz review day. So, for most of you, it was the stories that were tough, right? So let's go. Where's your attitude? Read number 9 and go. In flying from Champaign to Peoria, those are 2 cities in Illinois, a student pilot sets a heading that is 11 degrees off course. Instead of going directly to Peoria, it's 11 degrees off. And how fast? The speed is 84 miles per hour. And it says after 15 minutes. The instructor notices an error and tells the student to correct it. Through what angle will the plane move to correct the heading, and how many miles away is Peoria? So here's our triangle right here. And this is our plane flying along here. So, again, we know this angle here is 11 degrees. So I'm going to say again that you're talking, you're not thinking. I think it's rude on the video, and that can stay on the video. And I know you're not strong at this. So what choice are you making? Really? You're not making the choice to get stronger, think, draw through it, and so on. You're quitting. And all you're trying to do is talk over it and not apply it. You're tired or whatever else you think you are. So, I need us to apply this together. So, this was similar to your quiz. I need to find the missing side. The plane went 15 minutes at 84 miles per hour. I need to know that distance. There's a formula to find distance. It's called rate times time. And the speed of the plane is 84 miles per hour. And the time. Now, the issue with the time is the speed is in miles per hour, and yet the time is in 15 minutes. I need it to be the same unit. It can't be 2 different ones. So I'm going to change it to hours, and you know this. What part of an hour is 15 minutes? So I'm going to take my calculator, go 84 times a quarter. How many miles did the plane go before it turned? Next, now that you found it's 21 miles, what I need to do first is find the missing side. I can't find the angle before I know all the sides. This is the law of cosines. Side, angle, side. Take a side, square it. Take another side, square it. Minus 2 times 21 times 75, and then the cosine of 11. So, that missing side, how far is the plane from Peoria? And it's 54.533 miles. So that's one part. How far is the plane from Peoria? There it is. Then the next part is, what angle should the plane turn? Well, the angle that the plane should turn, the turning angle, is actually the angle outside the triangle. So if I extend the line, the angle outside the triangle is the one that the plane should turn, right? If you see it physically. But in order to find it, what angle do I need to find the turning angle? So how do I find the angle inside the triangle? So what's opposite? And then the other sides, including 54.533, put it in the formula. Now this answer is not my final answer, but it is the one inside the triangle that I need. So that angle is 164.789790. But that's not the angle the plane is going to turn. That would be a big angle, right, that the plane would turn to be off course? So that's the angle inside the triangle. How do I find the turning angle that the plane needs to turn? So we're going to subtract 180. So 180 subtract that. And the actual turning angle is 15.210. So how far is the plane away and the turning angle? All right, so the next questions that you need to practice, I'll put on video for you to practice. All right, Mr. G. Math, over and out.